follow a more exact approach. All right, so for the next example, we basically have two right triangles inside of each other, and it was kind of funny. The reason why I typically don't do word problems, but the reason why I want to do a word problem like this is because right now, this is a chapter that we're doing in my class, applications of trigonometry, and we're doing a lot of word problems. And one of the things that comes up with the students just took a quiz is they'll create a picture from the word problem, but then they'll just try to do the math. And, you know, I think it's really important for students to really understand, like, a lot of times, even when I taught geometry, students would still make this exact same mistake, is, you know, not having a hard time of like dissecting what information you have. So based on the word problem, this is the information the student had. We have an angle of elevation of 20 degrees, another angle of elevation of 15 degrees, and then these 2 points, which I think were observers, were like 100 feet apart or meters or whatever. And basically you want to find out the height. So the important thing here, and actually we don't even know this is X, but this is what I was doing in my head just to make sure that there was nothing crazy going on. We basically have like two triangles, and this is what I wanted just to help the student out with. So we have this one triangle. Here's like 15 degrees. We know this is a right angle. Here's H. Now we know from like here to here, we're going to say is like 100, but we don't know this distance from here to here, right? So let's go and look at the other triangle. Well, the other triangle has 20 degrees, and this is H. But again, in this case, we don't know what the side length is. So what we're going to do is we're just going to call this like X. And actually, let me just redraw the triangle like down here. Therefore, they're right next to each other. So then this is going to be represented as 100 plus X. Okay, now this is important because even though now I have two variables, right? But the important thing is, just like a system of equations, if you have two variables and you have two equations, you can solve. In this case, we have two variables and two triangles. So I can create a separate triangle for each one. So in this case, I'm going to do the tangent of 20 degrees equals opposite over adjacent. And then this one, I'm going to have tangent of 15 degrees. And that is going to equal opposite over adjacent. Okay, so now you can see that they both have the variable h. I can go ahead and solve. So I can say h is equal to x times the tangent of 20 degrees. And here we can say h is equal to 100 plus x times the tangent. Let's go and close that. Put that back up there. Tangent of 15 degrees. There you go. Okay, so now since they're both equal to x, I can now set them equal to each other and solve for x, right? So that's the power of being able to have these two variables here. So it's basically like another system here, right? We have them both set equal to h. So now I can set them equal to each other and go ahead and solve for x. You can evaluate using a calculator, which I don't have with me. So therefore, that's why I'm just going to leave it here. You could distribute here. So you'd have 100 times the tangent of 15 degrees plus x times the tangent of 15 degrees, right? So you're going to distribute that. Basically, what you'd want to do is get those x's to the same side, and then go ahead and you can combine them and go ahead and solve for x. Then once you have x, you can